Generative AI is now part of everyday work and learning, and almost all paid models are charged based on token consumption. Why do tokens play such an important role in generative AI? It's not just important. It's one of the first core concepts of generative AI. So today's topic, tokenization, brings you to the world of tokens. When you type a prompt into a generative AI application, the model does not receive the sentence in the same way that you read it, because it cannot process raw text directly. The text must first be divided into tokens. Each token is then mapped to a numeric identifier called a token ID. The model's embedding layer converts these token IDs into numerical representations that the neural network can process. By converting raw text into token IDs, tokenization bridges human language and model computation. This is how tokenization works. A common misunderstanding is that one token always equals one word. It does not. A token can be a single character, part of a word, a complete word, punctuation, or a common character sequence. In this example, generative may be divided into generative, and some tokens may even include a leading space. The exact result depends on the tokenizer the model uses. Why did generative become generative? The tokenizer is not applying an English grammar rule. Instead, its vocabulary was created from patterns found in large amounts of text. A character sequence such as active appears in words like creative, innovative, and informative. It may therefore become a reusable piece in tokenizer's vocabulary. Frequently occurring character sequences are more likely to become larger reusable tokens. Less common words, unusual names, or unfamiliar strings may be divided into smaller pieces. The result may look like linguistic analysis, but it mainly comes from vocabulary construction and the tokenizer's encoding algorithm. It is important not to confuse tokenization with semantic understanding. The tokenizer does not first understand a sentence and then decide how to divide it. Instead, it applies a predefined vocabulary and an encoding algorithm. It only means that the relevant text pattern exists in its vocabulary. Tokenization is not only used to process the input, it is also part of how a language model generates its response. After receiving the input tokens, the model predicts a probability distribution for the next token. Based on this probability distribution and the generation settings, the model selects one token and adds it to the sequence. The model then predicts the next token. Finally, the generated token IDs are decoded back into readable text. So a language model does not literally generate the next word. It generates the next token. Tokens also define several practical limits of an AI application. The context window is the total amount of information the model can work with during one request. This budget may need to include system instructions, user input, conversation history, retrieved documents, tool results, and the generated answer. If these elements use too many tokens, some content must be removed, summarized, or reorganized. Many AI services also calculate usage and cost based on input and output tokens. Larger token volumes can increase both cost and response latency. This means token count is not just a technical detail. It is a resource that must be managed. Once we understand tokenization, many other generative AI concepts become easier to explain. In prompt engineering, we balance useful information against the available token budget. In retrieval-augmented generation, Documents should be divided using both meaningful boundaries and token limits rather than character count alone. In agent workflows, conversation memory, planning steps, and the tool results all consume context. Fine-tuning examples are also converted into token sequences during training. Instructions like skills and content returned through Model Context Protocol or MCP servers may also enter the model's context. These technologies solve different problems, but they all operate within token-based limits. The most important idea is simple. A generative AI application begins with human language, but the model receives token IDs, converts them into numerical representations, and generates a response one token at a time. Once you understand this, the context window is no longer an abstract limit. API cost becomes measurable. Rack chunking becomes an engineering decision. Agent memory becomes a resource that must be managed. This is why tokenization is the first core concept to learn when studying generative AI. This is AI Espresso, where we learn AI concepts and how to build practical AI applications. See you next time.